Howdy PreCal, it is Ms. Kosh. I am finishing up the notes. This was solving polynomial equations where we started with dividing and all this lovely stuff, and now we're actually getting to polynomial equations where we can actually start solving. Okay, so I'm going to start by listing the possible factors. So it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6 came from this constant term. They're all divided by plus or minus 1 or plus or minus 2. And so if I'm dividing, this would give me plus or minus 1, 2, 3, and 6 when I divide by 1. And then 1 over 2 is 1/2. 2 over 2 is 1, which I already have in my list. 3 over 2 is 3/2. And 6 over 2 is 3, which I also have in my list. So there are the possible factors. Okay, and so now what we want to do is we want to do synthetic division. And I did already work this, and I'm trying to finish all the homework and the notes and the practice for you, and so I have forgotten what the right answer is. So I'm going to pick one of these rational numbers. I'm going to start with 2. I don't know. Okay, and so bring down the 2, multiply by 2, I get 4. I get 5 times 2 is 10. This gives me a -3. Oh my goodness, you guys, look at this. I got lucky the first go. So this is -6. I know it works if I get a 0 right here. This is when life is good. Okay, the other thing we could do is we could plug this into Desmos and look and see, and I will let you use a calculator, but I want to see that you know what you're doing. And actually, a lot of times you might get part of your answer from the calculator, but then the calculator won't be able to give you the kind of answer I'm looking for the whole thing. Okay, we'll talk about that in a second. Okay, so this f of x is now equal to an x minus 2 from here, and times 2x squared plus 5x minus 3. Does that factor? Well, that would be nice if it did. Let's see, 2x times x would give me a 2x squared. 3 times a 1 gives me a 3, and I need to make one of them negative and one of them positive, and I think there we are. Repeats 1 and 2 until you get to the quadratic. Oh, okay, well, I'm not really following their boxes. But I got lucky on the first one out. If you notice the answer key that I posted in class, I didn't get lucky the first time. So I shrunk my work and tried it again, and I didn't get that remainder of 0 till this time. So now what are my zeros? I have x equals 2. I add 1, divide by 2. I have x equals positive 1/2, and I have x equals -3. So that was kind of fun. Okay, so the next one, they're saying use division and begin factoring. So let's do synthetic division since we are going to divide by -1. Once again, this is the factor. We want to use the root, and so you have to change the sign right there. I wanted this to go away. There we go. So let's hang on. I have a 1, I have a -1, I have a -5, I have a 3, I have a 6. That was 4, 3, 2, 1, 0. Okay, I didn't have to put it in any blank space, any zeros to hold space. 1 times -1 is -1. This gives me a -2. This gives me a +2. I see a -3 times a -1 is a +3. This gives me 6 times -1 is -6. Oh, that's convenient. And there's 0. Okay, so where am I right now? I now have f of x is equal to an x plus 1 times x cubed minus 2x squared minus 3x plus 6. And what I'm hoping, one of my favorite ways to factor is to factor by grouping. And when I look at this, I'm thinking, maybe if I factor here and then here, this will work out nicely for us. So this is kind of scratch work for a second. X squared times x minus 2. Then I can factor out a -3 times an x minus 2. Oh, here we are. Okay, so my function f of x will be equal to an x plus 1 times an x squared minus 3 times an x minus 2. Okay, so now what does this tell us? Well, it tells us that I have a 0. My 0 from here is x equals -1. My 0 from here is x equals 2. And this one I can solve. What we'll do is we'll say x squared minus 3 equals 0. I'll add 3 to both sides. And then I'll do the cheer, square root, plus minus. And so x equals plus or minus √3. Those are not rational answers, but they are real answers. Okay, so your calculator or Desmos would have shown you this one very clearly, this one very clearly, and this one would have been a nasty decimal. Okay, those two would have been nasty decimals. Now, maybe you knew it was √3, but odds are you didn't. So you would probably need to do the math so that you could show me I'm looking for an exact value. Let me show you what I'm talking about. If I have, hang on, where did Desmos go? Oh, that's not what I wanted. Come back, Desmos. Where are you? There you are. Okay. Let me split my screen. There we go. And now let me make it so that I can read it. X to the fourth, and go over, minus x to the third, and then I have to go over, minus 5x squared plus 3x plus 6. Here's my graph. What the heck is happening? Oh, you know what? That screen is going to be... Did you see what I did there? When you have scrolled out in some capacity, do you see that house-looking thing? That sends you home to your zeros, which is great. Okay, so if I look at these zeros, I have this, and this. 2 of those are nice and easy to understand. The other 2, I would not accept a negative 1.732. I want to see that you know how to get to negative root 3 for that one. Notice here, well, let me show you what I'm talking about. Root 3 is equal to that, which is this, this value and that value. One of them is positive, one of them is negative. But I want you to be able to get to root 3. Okay. We finished that one. Okay, so the next one here, this one I like to do what's called a U substitution. Not a me substitution, but a U substitution. All right. And so what I'll do is I'll say let U, not me, equal x squared. Well, if U is equal to x squared, then U squared would be x squared squared, which is x to the fourth. And so I can rewrite this as U squared minus 5U minus 36. I'm going to set this equal to 0. And this is something I know how to factor. U, and one of them is minus 9, and U, and the other one is a plus 4. And so now I have factored it, sort of, but I need to go back and plug in my x squared. And this one I might recognize as the difference of squares, so this becomes x minus 3 times x plus 3. This one, however, we have kind of looked at this. X squared plus 4 equals 0. I have to subtract 4. And now I'd go square root, plus minus, and I get x is equal to plus or minus, the square root of 4 is 2, the square root of negative 1 is I. And so I could factor this and say x minus 2i and then x plus 2i. I don't know that I care that you write out all those factors, but I do want you to tell me that the answers are plus or minus 3 and plus or minus 2i. Okay, the next one, oh, I look at that and I'm like, I don't know. It doesn't factor by grouping. I can't, if I factor out an x squared here, I get an x minus 4, and that's not gonna, nothing factors out of those two. So that's not helpful. What I would do with something like this is I would go find Desmos. And I would clear out this mess. I would x cubed minus 4x squared minus 7x plus 10. Okay, and let's now make this big enough so that we can see what's happening. Ah, I see 1, 2, 3 zeros. That looks good to me. Okay, so it's negative 2, positive 1, and positive 5. And so x equals negative 2, positive 1, and positive 5. Is that what I just said? It is. What do I want you to show me? I mean, maybe I want to see that you did the synthetic division. To be honest with you, what I would probably do is I would probably mix something like this with something where you could see on your, I might give you something where one of the zeros is easy to find in Desmos, but then the other two are like 3 plus or minus root 5, and then you have to do some math to get me this, and you can't get that from the from Desmos so easily. That's what I intend to do to make sure that you're doing things properly. Hang on, I want to get rid of all of, oh, my pencil just turned off. Okay, let's see if I can get rid of all that. Why am I not seeing delete? There it is. Okay. Okay, the next one, oh, this is the difference of cubes. And we have this rule, I'm going to do it up here, and I like to call that SOAP. And so what we do is if we have a cubed plus or minus b cubed, the way I think of it is a squared, b squared. And then the signs are the same. It's the opposite. It's always positive. So same, opposite, always positive. You know, I think Miss Bellish might have a different way to teach this. I'll have to ask her. But this is how I remember, how I've taught it for years. So, okay. On this one, what I like to do as I get started is write out, okay, a cubed is equal to this x cubed. B cubed was equal to 8. Okay, so if a cubed is x cubed, that means a is x. That means a squared is x squared. Now, you may not think you need to write this, and you may not need to write this. But if you're worried that you're going to make a mistake, I would write this. Okay, the cube root of 8 is 2, and so then b squared is equal to 4. Okay, so then when I write this down, I remember a squared, b squared. Okay, so I just kind of have that rhythm in place. So now I look back up. What was a? It was x. What was b? It was 2. A squared was x squared. AB is going to be x times 2, or 2x. And then b squared is 4. And now my sign is the same. This had been a minus. This is the opposite, so this is a plus, always positive. Okay, so now we have found one of our zeros, and that's x is equal to 2. But now we have this other one that's going to give us some zeros. So here, this one won't factor. It just, when you have the difference of cubes, the one will work out nicely and the other one won't factor. So what I would do for this one is I would complete the square, because I think that this lovely little 2 makes my life easy. I moved this over, it becomes a -4 when I switch to the other side, and I have plus a box. So I'm doing x squared plus 2x plus a box equals -4 plus a box. And so then this right here, I want to take x, half of 2 is 1. I want this squared. So basically what's happening is that this and this are now equivalent. And, okay, but if I put a 1 in this box, I have to put a 1 in that box, and this becomes a -3. And then I have x plus 1 is equal to this, well, I might go square root, plus minus, and this is plus or minus I root 3. And so my final answer, my final set of roots is -1 plus or minus I root 3. So I had this as a 0, and I had these as zeros. Okay, that was fun. Let's look at this next one. When I start here, I'm going to try, I see that I can factor out a 3x, and this gives me an x squared plus x minus 3. Does that factor? No. That's annoying, right? Did I do that correctly? Yeah, I think I did. So there's nothing that multiplies to give me 3 that adds to give me 1. So, and this one, I would probably not complete the square, because this is not an even number, and then you're dealing with fractions, and it's just gross. Okay, so I have 1 0 of x equals 0 from right here. And then I have the quadratic formula, x equals, so if you remember, ax squared plus bx plus c equals 0, then it's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. I have a little bit of congestion, so singing's not my natural strength, but, you know, anyway, I'm willing to sacrifice myself for y'all. Okay, plus or minus, so it's -1 plus or minus the square root of b squared is 1 minus 4 times 1 times -3 all over 2a. And so I see x is equal to -1 plus or minus, I see 12, a positive 12 plus 1 is 13 over 2. And so here are my answers. All right. Okay, so this next one, they gave us a factor. And let's see how that helps us. So I'm going to come along and do synthetic division with a -2 out here. 2, 3, -6, -6, positive 4. Did I have any? I went 4, 3, 2, 1, 0. I always have to check. So 2, that gives me a -4. This gives me a -1. That gives me a positive 2. This gives me a -4. This gives me a positive 8. This gives me a 2. And a -4. Sure enough, that's a 0. Okay, so what do we have? We have that our f of x is equal to x plus 2 times a 2x cubed minus x squared minus 4x plus 2. And I'm hoping I can factor by grouping. So let's try factoring by grouping. I can factor out an x squared, leaving me with a 2x minus 1. I can factor out a -2, leaving me with a 2x minus 1. Okay, that was kind of scratch work. So then I'm back to x plus 2 times 2x minus 1 times x squared minus 2. This is going to give me a 0 of -2. This is going to give me a 0 of +1/2 because I added 1 divided by 2. And then here, let's do the cheer. X squared minus 2 equals 0. X squared equals +2. Square root, plus minus. X is equal to plus or minus root 2. And so I had 4 zeros, and here they are. This is what I would like to do in a problem. I would like to give you something where there are rational numbers where you could find them on Desmos, but there's also something irrational or non-real that's going to require you to know a little math. I think, oh, look at that. We got to the end of our notes. All right, like, subscribe, comment, and go practice.